So thank you very much. So my name is Kjetil. That's the Norwegian way and nobody gets it. It's only Norwegians that can do that. So it was a good attempt. So I'm a research director at NILU, and I'm giving this talk as in my capacity as being head of the EMAP Chemical Coordinating Center. So actually, I will try to make an introduction to the EMAP program. And EMAP, I assume that you may have heard about this program. It's a rather long-lasting story. It started officially in 1977. It was a program established to abate acid rain in the Scandinavian lakes. One could in the 60s and 70s see that the salmon populations they disappeared, and there was some Swedish scientists that were able to prove the fact that it was sulfur emissions in the UK and Western Europe that led to this acidification. But this scientific consensus, this was reached after a project that ran through the 1970s, which was called this OECD project, and that was coordinated by NILU, and it ended up with NILU becoming the coordinating center of the EMAP program following that. So there's something called the EMAP protocol. This is a funding protocol that now funds 5 technical centers that do the work, and the EMAP Chemical Coordinating Center is one of these 5 centers. And my focus will mainly be on the work that we do here at NILU as EMAP CCC. But I will also partly talk about what the parties to the EMAP protocol have in obligations. So I mean, Serbia is, for instance, a party to the protocol. So a lot of my focus will be on how we try to engage countries to become active in the EMAP program. Because if you are a party, you are expected to report emissions data, but also to implement the monitoring strategy of EMAP. And as a chemical coordinating center, we are trying to coordinate the observations across the European domain, and we collect the data and we make the data available for scientists and for policymakers. And I think in my focus now, maybe I will try to say a bit what happened around the year 2000, because before the year 2000, it was the focus on ecosystems that was running the convention. I mean, pollution and deposition. This is what the main focus was. We started with acid rain in the 70s. Then we had heavy metals and ozone and ozone precursors. And then the nitrogen cycle came in around 1980. And then POPs came in around 1990, while aerosols that entered the program around the year 2000. But before that, we had, of course, the chemistry of the inorganic substances, like the sulfur chemistry, the nitrogen chemistry, and base cations, mineral dust. This was part of the program, but the focus was on acid deposition and neutralizing capacity, and not on health issues. So the health issue came about in the mid-1990s. I mean, that was the time when one could really prove that also transboundary pollution of aerosols led to an effect on air quality, even in cities. And for many cities, still the contribution from the regional background is a dominating factor of the aerosol concentration in the cities. So in 1999, it was decided that the convention should start to develop its focus on aerosols, and this was also the time when aerosols came on the agenda on the climate perspective. So the radiative forcing of aerosols was also a very high research topic in the years after year 2000. So what we did at that time was first to write a review on what is known about atmospheric aerosols. And then we also had this quite important workshop in 1999. This was co-organized with the WMO Global Atmosphere Watch Program, trying to bring together experts from the countries in deciding how to deal with aerosols. What do you need in terms of reporting emissions? How do you model this, and how do you measure to understand whether you have the correct emission data if your models are working correctly? So this was also in 1999. And then in EMAP, we have something called the Task Force on Measurements and Modeling. This is a forum where national experts can participate. It's an open forum, but it's the core ambition of this forum is to bring together people and to have collaboration. And the first meeting of this EMAP TFMM, that was actually in 2000, and it had as one of its major focus areas was to discuss this background information and to come up with recommendations on how to implement aerosols in the program. And if you go to this website, I hope you will share these presentations later. You can find the links to the things that I'm presenting now. And now we have had 23 task force meetings, and you can find all the presentations and all the minutes here. I'm getting old, so I like to look at these old papers. But it's a lot of interesting history here. And if you go also back to 2000, this was the first note that we produced at EMAP CCC on how to do the measurements of aerosol particles. And at that time, it was, first to get countries to start measuring PM mass concentrations, and also to improve the chemical speciation of particles. And also later, we took in the physical and optical properties of aerosols. And the first status report that was also produced in the year 2000. And this report gives an assessment not only on observations, but also about measurement strategies. At the same time, in Europe, there was a big research activity going on called Eurotrack. And Eurotrack had as one of its sub-projects an activity on aerosols. And this was also very, very important because it brought together the academic community of Europe. And we quite early understood that one of the key challenges was understanding the carbonaceous aerosols. So already in 2002, we established the first European-wide monitoring campaign to measure the concentrations of elemental carbon and organic carbon across Europe. This paper came out in 2007, but the data goes back to 2002, and some stations, they have now been running operationally since 2002, and you have time series. I will show examples of that. In 2004, there was also a big European assessment on the European aerosol phenomenology, led by JRC, but where there was data that, you can find most of the data that was available at that time were included in these two papers. We also wrote a paper where we tried to justify how to come up with these monitoring requirements for the EMAP program. This came in 2004, and here as it looks today now. I will not go into the details, but to make it very simple, parties to EMAP, they are expected to have both what we call level 1 stations and level 2 stations. Level 1 stations, they are very well defined. So you need to measure ozone, you need to measure PM mass concentrations, and you need to measure EC and OC. In addition, one are expected to also have what we call level 2 activities, but not necessarily on aerosols, because here you have different scientific categories you can choose from. This depends about the national interest. But if you want to have an aerosol level 2 station, then you have to also to have the physical and optical properties determined at the stations. And at the bottom here, you can find the link to the official document 2012. It's now getting 10 years old, but still I think it has all the history and a lot of the base information about the EMAP program. It's described in this paper. Here we can see the different protocols at the bottom in yellow when they were established, how the program expanded from sulfur to NOx, VOCs, heavy metals, POPs, and now we have this Gothenburg protocol that also now regulates particulate matter emissions. You can see the number of stations in the left axis, and then the colored lines. So the red line shows that there is now about 100 stations that measure sulfur in precipitation, for instance. And on the right axis, you can see the number of countries, number of parties that report level 1 and level 2 data. So we are currently about 35 of the 42 countries are active in reporting data. And here is how it looks if you look at every single country and check if they do the implementation of the monitoring strategy for level 1. Here you can see Serbia here, so you have an implementation index of about 15% in 2019. And you can see also here to the right that some countries, they have improved their monitoring, but there are also countries that have reduced their monitoring or data reporting. You have one active station in Serbia at the moment, and you measure PM10 and ozone. So it's partly implementing fully the level 1 program, as I mentioned. And here is the active sites across Europe. And relevant here is then the PM. We have 78 stations, 23 countries. You have aerosol properties. You have 50 stations from 17 countries. Yeah, and you also have the inorganic chemistry, 136 sites from 33 countries. And if you want to look at all this data, you can visit the database. You will find the link here at the bottom, and you can just select country and the substance, and you will see what data is available. NILU is also working closely with the WHO Global Atmosphere Watch and are hosting now the World Data Center on Aerosols. This has been running since year 2010. Before that, this was a responsibility of the JRC at ISPRA. Data that are in EBAS, they are extensively used. We have in the order of 250 to 300,000 downloads per year. And we can see applications of the data in many reports and publications, for instance, in IPCC AR6. And these are the kind of results that are often asked for, is to show the trends. At the bottom here, you can see particulate matter mass trends, PM10 and PM2.5. And you can also see these trends that I mentioned for EC and OC, that here is shown back to 2010. But for some stations, we also have data going back to year 2000. Another big and important activity of EMAP is to have what we call intensive campaigns. We had this campaign in winter 2017-2018, where people were asked to report absorption data together with tracer data like levoglucosan and also EC-OC data. And from the absorption measurements, it's possible to make a distinguishment between different sources to carbonaceous aerosols. And just to show how that looked across these stations, I mean, some of them are urban stations and some of them are background stations. And you can see the diurnal variations in these fractions that are either from fossil fuel or from biomass burning using a PMF approach. And here it's sorted based on this this ratio, and you clearly see here that for stations that are, I mean, it's a large spread, but for many stations, domestic heating is a major source of coarse fraction organic carbon. Finally, I would like to, because now I mainly talked about the measurements, but in addition, there is a center in Austria that collects the emission data, and there is a center in Oslo, the Met Service of Oslo, that do the CTM calculations. And every year we produce reports for policymakers that describes, the levels and the trends and the developments in the model code and things like that. And here you can also find country reports to see how much pollution is admitted in one country and ending up in another country. So I did not go into those kind of slides, but I really recommend you to have a look in these quite extensive reports that are available. And finally, just two links here. One is to the EMAP webpage and to the EMAP CCC webpage. Thank you very much.